Now, empirical study of how individuals actually take decisions show that we really do not conform to what the normative theories of rational decision making say. In fact, individuals tend to exhibit a number of biases, so tendencies to respond in certain ways. Individuals tend to use heuristics, rule of thumb, to take decisions as opposed to calculating expected utility. Um, and this leads us to commit certain fallacies. So let me give you some examples of each of these cases. So let's start with a bias, and, which illustrates something called a framing effect. And in fact, I only realized how uh, timely, I guess, this classic example by Kahneman and Tversky is for these days. Imagine that the US is preparing for an outbreak of an unusual tropical disease, which is expected to kill 600 people. Now, two alternative programs to combat this disease have been proposed. Um, and assume that you know exactly the scientific facts about it. So you have two choices. Which of the two are you going to pick? Now, if you pick program A, then 200 people will be saved for sure. On the other hand, if you pick program B, then there's 1/3 probability that 600 people will be saved, but there also is a 2/3 probability that nobody will be saved. Which one would you pick? Let's try the same scenario, but slightly amended. Imagine that a new microbe has been discovered in the waters of New York, and it's estimated to kill 600 people. Two programs have been proposed to combat the outbreak, and again, assume that the numbers you're going to get are correct. Program A says that if you adopt it, 400 people will die for sure. On the other hand, if you pick program B, there's a 1/3 chance that nobody's going to die, and a 2/3 chance that 600 people will die. Which of the two programs would you pick? Now, I want to guess that in the first scenario, you picked the 200 people will be saved for sure, which was program A. But in this scenario, you probably picked program B, or at least this is what people tend to do. Now, as you probably have noticed, all options in these two examples have the exact same outcomes. In both cases, the expected outcome is that 200 people will die, 200 people will be saved, and 400 will die. The only difference is that in the prior version, it was framed in terms of people who will be saved. And in this circumstance, we tend to be risk averse, right? When we're dealing with gains, we tend to not like risk. We prefer 200 people saved for sure to the odds of maybe saving 600 people, but maybe with greater chance not saving anyone. On the other hand, again, given the exact same expected outcome, when the problem is framed as a loss, we like the chances of 1/3, 33% chance that nobody dies versus 66% that all 600 people will die. And in fact, when it's shown in a loss format like this one, people tend to choose B. People tend to choose the risky option. And yet again, this and the prior problem were exactly the same problem. Just because of the way in which something is presented, that in of itself biases our choices. And this is known as the framing effect. It's a bias that occurs when our decisions are influenced by the way in which information is presented to us. In other words, the exact same information can be presented to us, but can be made more or less attractive, depending on how it is framed, how it is presented to us. And see, if you think back to the expected and subjective utility theory, this is a clear violation of that independence number 2 axiom, the one that sounded a little strange. The one that says that if you like A better than B, you always like A better than B. Well, see, this didn't happen here, right? Now, a second type of bias is known as the endowment effect. Now, the endowment effect is a bias according to which people tend to place a higher value on objects that they already own compared to objects that they don't own. So given the same object, just because you own it versus not owning it, changes your preference structure over these objects, which again goes against the idea of the axiom of independence. Now, Netsch in 1989 did a very clever experiment to demonstrate this. Now, they divided participants into 3 groups, and the 3 groups kind of went like this. You show up at the experiment, and either you're not given anything, or you're given a mug, or you're given a bar of chocolate of just about the same monetary value of the mug. All right, so either you didn't receive any gift, or you received the mug, or you received the chocolate. Now, next, participants are told, look, did you actually want a mug or a chocolate? Meaning, participants, if they didn't receive anything, they can choose if they want a mug or a piece of chocolate. If they receive the mug, they can decide if they keep the mug or they want the chocolate. If they receive the chocolate, they can decide if they want to keep it or if they want to give it away. Now, here's what's so interesting. The participants that didn't receive anything, they kind of went, not 50-50, but, slightly uneven, but almost half and half. They went for the mug or the chocolate. So if you just take a random sample of people, they divided, somewhere close to half and half between mug and chocolate. Now, here's what happened to the people to whom you first gave a mug at the beginning. Suddenly, they really want to keep the mug. It's as if the mug was really, really valuable to them. On the other hand, the people that received the chocolate at the beginning, they really wanted to keep the chocolate. And see, what's so odd is that if you just take random people, they go 50-50, well, or close to, like this group. On the other hand, if you're given something, instantly that something has greater value, right? So people seem to value the item that they receive more just because they received it. So again, this is showing that our preference structure doesn't quite look like what expected utility theory says it should look like. A related bias to this one is the so-called IKEA effect. Now, Norton and colleagues had a number of participants either assemble IKEA furniture or folded origami or Lego creations. Then they actually built copies of the same item, and they asked if participants wanted to purchase them, and for what price. Turns out, what they found is that participants were more likely to pay money, and in fact, to pay more money for the items that they had assembled compared to those that the experimenters had assembled. So just because you put in sweat into something, suddenly the value of that something is greater compared to the exact same item, but that somebody else has built. Okay, so if you were to purchase that item, you'd go home with the exact same item, right? But somehow, because this particular one is the one that I sweated on, as opposed to this other one that is the same, but you built it, somehow this object is much more valuable. It makes no sense according to the tenets of expected utility theory. It's the same object. How can it be more or less precious just because I built it versus somebody else built it? It's the same thing. It has the same value. And finally, a last example of bias that I want to mention has to do with emotions and has to do with, so it sort of comes in the context of moral decision making, and it's known as the trolley dilemma. It goes like this. A trolley is approaching 5 people who are tied to some railroad tracks. Now, you just happen to be standing nearby a switch that could cause the trolley to change to switch tracks. However, there happens to be one person on that other track, as you see in this drawing. Question, would you flip the switch? Would you do it? Would you flip the switch to save 5 people and kill one? How about this other one? A train is approaching, 5 people tied on tracks. You happen to be standing on a bridge that is just directly over the tracks. And in fact, nearby you, there's a really large gentleman. And you estimate, in fact, we have to say that you're certain that if you were to push the gentleman on the tracks, that would stop the train, effectively saving the 5 people who are tied on the train at the cost of the life of the person you're throwing down the bridge. Would you push the person off the bridge? And see, what seems to happen is that most people, although everybody struggles with this kind of scenario, a large majority of people in scenario A are willing to flip the switch, are willing to say, look, I know it's terrible, but I'm saving 5 people and only one person is dying. So in aggregate, it's a positive. Given the exact same so-called payoff structure, so given the same 5 versus 1, but in the footbridge example, people by and large do not seem to be willing to push someone actively off a bridge in order to save those same 5 lives. Again, this makes no sense. It's the exact same options. Just because they're worded differently, we again seem to behave differently. And this once more violates the axiom of independence number 2. If you like A better than B, save 5 to the cost of 1, then you should always like A better than B, save 5 to the cost of 1, regardless of whether you're flipping a switch or actively pushing someone. So these are nice examples of how even sort of tendencies that we have violate the basic principles of the normative approach to rational decision making.